Hi guys, my name is Fuan Maharani and people call me Fuan. I am currently majoring in chemical engineering at Kuala University. I am leading the team to participate in this event, International Walisongo Science Competition. Cheers guys, have a great
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Rashida. I'm from Chemical Engineering Department, Kuala University.
Assalamualaikum everybody. I am Fuan from Chemical Engineering Department, Kuala University. I am member of the team for participating in this paper competition.
Findings from a new study support the Kent County Department of Public Works' plan to open a new business park dedicated to drastically cutting the county's waste. Currently, Kent County collects around 1 million tons of waste each year, and while 100 tons are recycled or reused, around 612,000 tons of trash just from homes and businesses end up in the landfill right there. But a lot of that trash can be reused and recycled, keeping more things out of our landfills and thus cutting carbon production.
Population growth has experienced a significant surge. The United Nations estimates that in 2050 it will reach 11 billion. The increase in population will increase the need for food and energy. Current energy still depends on fossil fuels, while the contribution of renewable energy such as solar, wind, water, geothermal and marine energy globally is only around 7%. For the case of Indonesia, the mix of renewable energy to the national fuel consumption also revolves around that figure. Above 85% of the national fuel is filled from fossil fuel. If no new wells are found, Indonesia's oil reserves will only be able to meet national needs for the next 12 years. This is a worrying situation, if there is no solution to overcome the dependence on fossil fuels. Another problem, an increase in population will also result in an increase in solid waste production from households. In 2020, Indonesia produces around 67.8 million tons of solid waste. Unfortunately, most of the landfills in Indonesia are still operated as open dumping sites, so they have a very negative impact on the environment. In general, more than 50% of the composition of domestic waste is dominated by organic waste, food and plant waste. And this organic waste has not been used at all to be used as a product that has economic added value. So far, there is still plastic waste that is used for recycling with the help of scavengers. If only organic waste, such as food waste, could be converted into value-added products, the national waste volume would be significantly reduced. Even though it hasn't been completely handled, there have been efforts to recycle plastic waste. But unfortunately, attention to food and other organic waste is still minimal. It should be noted that this organic/food waste is waste that will continuously be produced by humans, therefore this waste is renewable. Associated with non-renewable sources of fossil fuels, food/organic waste is a very potential resource to be converted into fuel and to replace fossil fuels in the future. Why this can happen? Because the content of organic carbon compounds and other nutrients in food waste can be converted into energy materials and value-added products through appropriate processing processes. On the basis of this potential, we propose to convert food waste into bio-oil through hydrothermal liquefaction and hydro-treating processes. If this study is carried out experimentally, it will be very expensive and take a long time, because it requires treatment at high temperatures. Therefore, we conducted a simulation study using the AspenHysis V.10 software. How is the process of converting food waste into bio-oil? Consists of two stages. The first stage is hydrothermal liquefaction followed by a hydro-treating process. In the first stage, hydrothermal liquefaction technology is used to convert solid waste into biocrude. The results obtained from the first stage are still in the form of biocrude, which has a higher oxygen and nitrogen content than petroleum, so hydro-treating is necessary to make it suitable for petroleum fuels. At the hydro-treating stage, the oxygen content in the biocrude becomes CO2 and water, nitrogen is converted to ammonia, and sulfur is converted to hydrogen sulfide. So that the resulting product consists of paraffin, olefin, naphtha, and aromatics, which are in the boiling range of gasoline. A product resulting from a reaction is largely determined by the yield of the reaction. The greater the yield of a reaction, the more products are obtained. The waste management system in Indonesia is not yet integrated, because the waste disposal sites are located in many places. Because the biocrude production unit system that moves is very suitable for cases like this. This model of a mobile fuel production system has been implemented in developed countries, such as the United States and several European countries, which produce biodiesel. Therefore, the same thing can also be applied in Indonesia, so we propose to develop a mobile biocrude oil production unit system.